Commission would come to order. Our final presentation today will be from Dr. John Garrick, Chairman of the U.S. Nuclear Waste Technical Review Board. He served as chairman since 2004, and prior to that, Dr. Garrick served for 10 years on the U.S. Nuclear Regulatory Commission's Advisory Committee on Nuclear Waste. He's the founder of the firm PLG Incorporated, from which he retired in 1997. Dr. Garrick, the floor is yours.
Thank you very much. I want to thank the Commission for inviting me here today to discuss some lessons learned from U.S. and international waste disposal efforts. My name is John Garrick. I'm the current chairman of the Nuclear Waste Technical Review Board. There are 4 members of the board in the audience today, so I have plenty of backup if I get in any kind of a jam. I know that 2 of your subcommittees have heard from other board members and staff, so I'm only going to very briefly describe the board and its role. The board is an independent federal agency. It has 11 technical and scientific experts. It is nonpartisan and apolitical. Members are appointed by the President to 4-year terms from a list of nominations submitted by the National Academy of Sciences. By the way, I should mention that former Congressman and current Commissioner Phil Sharp played a pivotal role in crafting an amendment that led to the board's existence in the 1987 amendments to the Nuclear Waste Policy Act. I know also that Senator Domenici played an important role in the passage of that legislation. The board is charged with conducting unbiased, ongoing technical peer review of activities undertaken by the Secretary of Energy related to the implementation of the Nuclear Waste Policy Act. In particular, we assess the technical and scientific validity of DOE activities to manage and dispose of spent fuel and high-level radioactive waste, which I lump under the rubric of high-activity waste. The law requires us to report our findings, conclusions, and recommendations at least twice a year to Congress and the Secretary. I should establish at the outset that the board's statutory mandate continues even as alternatives to a Yucca Mountain repository are being considered. The board's current review work and priority tasks reflect the transition of DOE's nuclear waste management activities to include potential fuel cycle alternatives to direct disposal of waste. Let me list very briefly some of the board's current priority tasks. Since June 2009, the board has reviewed the technical issues of long-term storage of commercial spent fuel. We're developing a white paper on this subject that will be used as a basis for our reviewing of DOE's research related to extended storage of both commercial and government-owned high-activity waste. Another effort supporting our ongoing review is a material balance analytical tool called New Waste, which was introduced to the Blue Ribbon Commission Reactor and Fuel Cycle Technology Subcommittee last month by my board colleague, Mark Abkowitz. The results provide important insights on the potential benefits of different back-end processes and activities, such as recycling of uranium and plutonium and long-term storage of spent fuel. To determine the technical effects of how a delay in repository availability affects the plans of federal facilities that store government-owned high-activity waste, the board has visited most of the facilities where these wastes are stored. We plan to issue a report early next year on our findings and conclusions. We are in the process of revising the report we published a year ago that presents information on the programs being developed in other countries for managing high-activity waste. And board staff member Dan Metley presented the original report to the Blue Ribbon Commission Subcommittee on a disposal subcommittee in July. The revised report will be extended to include a qualitative and historical assessment of how the countries we surveyed are going about developing their geologic repository programs, and it will draw some conclusions on how external factors have impacted the repository program in those countries. Last but far from the least is the board's preparation of a report of technical lessons learned from the U.S. and repository programs worldwide. This report will be made available to the Blue Ribbon Commission when it has become finalized. And much of the balance of my talk will be in connection with that report. First, however, the board feels compelled to express its support of the opinion that's been voiced by many others that regardless of the nuclear fuel cycle adopted, a repository for permanent disposal of high-activity waste will be necessary. In addition, I personally believe that having a plan in place for permanent disposition of the waste on which there is agreement and a path forward is essential to gaining public confidence in the nation's ability to manage nuclear waste. Right now, I think we have a temporary fix for a problem that very much needs a permanent solution. Government-owned high-activity waste is being stored at several federal facilities, and commercial spent nuclear fuel is being stored at more than 100 nuclear power plants nationwide at over 70 sites. The current inventory, we've already heard, is about 60,000 metric tons of heavy metal, and as we've also heard, and it's being added to at the rate of about 2,000 metric tons per year. So what is the solution? Well, that's, of course, part of what the Blue Ribbon Commission has been asked to consider. But deep geologic disposal must be at least part of the answer. The objective of deep geologic disposal is simply to isolate high-activity radioactive waste from humans and the accessible environment for durations that are unprecedented in our history. Of course, this is easier said than done. Slide 7 highlights some of the challenges and complexities. With these complexities and the resulting technical challenges as background, what lessons have we learned from the experiences of the Yucca Mountain program and other repository efforts that could help us achieve this important permanent solution? Every time I think or talk about lessons learned or learning from experience, I'm reminded of what President Truman once said, quote, "There is nothing new in the world except the history you do not know," end of quote. And the late great nuclear pioneer Walter Zinn, several decades ago, often pointed out that many scientists and engineers complain that there is too little data, when in fact the problem really, in most cases, is that we seldom take advantage of the data that's available. So in the spirit of President Truman and Dr. Zinn, the board has attempted to capture some of the nuggets from what has been learned during the last several decades from disposal efforts in the U.S. and other countries that might be useful in the future. Because we know the U.S. program from our own involvement, the Yucca Mountain Project provides the primary source of information for our retrospective. Obviously, we have learned much more about geologic disposal than I can cover in a few short moments, but let me give you a few examples. First and foremost, the cumulative experience of the Yucca Mountain program, the Finnish, French, Swedish, Swiss, and the Waste Isolation Pilot Plant program provides a high level of confidence that deep geologic repositories are indeed technically feasible. And it should be noted that the planned repositories for these programs and the operating waste isolation pilot plant are located in different geological environments, including tuff, granite, clay and granite, and salt. We learn to expect surprises when you get underground during the site characterization phase, so the sooner you go underground, the better. Two examples of surprises at Yucca Mountain were, one, the possible discovery of bomb pulse chlorine-36 at the repository level, which, if eventually confirmed, means that a small amount of surface precipitation could reach the repository level in just 50 years or less. And two, the discovery of a repository environment riddled with pockets. The technical term is lithophysa, ranging in size from the diameter of your thumb to the diameter of a basketball and larger, which considerably complicated geotechnical and heat transfer modeling. Another example of a surprise is that in the early days of the waste isolation pilot plant characterization, experiments with heat-generating surrogates demonstrated that the creep rate of the salt at higher temperatures was far greater than had ever been determined in the laboratory. We learned that including a robust engineered barrier system can have significant advantages over a program that relies primarily on what is referred to as the natural system. Because the materials and manufacturing methods used for the engineered barriers can be specified and controlled, confidence in their predictability may be greater than that of the natural system. Of course, this assumes that this environment in which the engineered barriers would operate is understood. The result can be much greater confidence in the form, quantity, and rate, that is the radiation source term, of radioactive material from the disposed waste entering the natural system. We have learned a great deal about the importance of analyzing the contribution to overall risk of different waste forms. A much improved knowledge base now exists to guide future efforts in specifying the most appropriate waste forms for permanent disposal. A disposal facility involves many first-of-a-kind systems and components for which there is minimum experience. A carefully planned and systematic program of prototyping such systems and components in their expected environments is essential to understanding and modeling their potential performance. We learned how important it is to have a waste package design that allows for direct disposal of a variety of canisters, including loaded dual-purpose canisters, to minimize the handling of high-activity waste. Waste handling is considered a significant contributor to the risk of any high-activity waste management system. Major advancements were made in the Yucca Mountain project on how to use the risk sciences to quantify post-closure performance over extremely long time periods. An important spin-off of this work is the use of phased and interactive probabilistic performance assessments to tell you what you should be doing in the characterization phase. We learned how important it is to implement a rigorous and integrated total systems approach to characterizing a repository site, developing a repository, and designing and operating a waste management system that involves such diverse activities as transportation, storage, packaging, handling, and disposing. It is important to know how decisions made in each functional area of the waste management system affect other parts of the system. In particular, the impact of decisions and design requirements having to do with post-closure have to be traceable to their impact on pre-closure activities, including waste handling and transporting, and the actual design and construction of the surface facilities for the project to be efficient in its operation. We learned that it is essential to have a close relationship between the science program and the engineering activities in such projects to control costs, schedules, and other performance goals. Experience indicates the importance of making the transition from a science program to an engineering project at the right time. And finally, experience tells us that a license application in the U.S. can be developed that meets the requirements of the Nuclear Regulatory Commission for accepting a license application to review. This was a major achievement. Now, experience in other countries could become increasingly significant depending on when the United States resumes efforts to site and develop a deep geologic repository. Some findings from the experiences of programs worldwide are: repository systems can be developed in a variety of geological environments. There's lots of evidence to that now. Most proposed disposal concepts rely on both natural and engineered barriers, although the degree of reliance on one or the other varies considerably. Research carried out at depth in underground research laboratories has been extremely valuable. These are some of the lessons that the board learned from its review of different high-activity waste repository programs, although I have only had time to present them at the highest level. As I mentioned, I believe that keeping a focus on a permanent solution is critical, regardless of what interim alternatives to managing high-activity nuclear waste are recommended. And the basis for this view is a permanent solution is critical to building public confidence that there is indeed a way of isolating high-activity waste. I don't think the public is convinced that this problem can be solved. History tells us that institutional stability is not guaranteed forever, and we're dealing with long-time constants here. The longer the delay in resuming a repository program, the higher the probability that it could be disrupted during the operational phase by institutional changes. An international scientific consensus exists that a permanent geologic repository is the preferred disposal option and that it is technically feasible. And in closing, the following are necessary. I believe the following is necessary for us to move forward. Number one, an assessment of repository development experiences to date should be used as a baseline for future geologic disposal programs. We have only really scratched the surface. Site selection and site characterization activities in the U.S. would benefit from such an assessment. Number two, characterization of waste farms together with existing inventories of high-activity waste should be revisited, and the issue of the optimal method of disposal for each waste farm should be addressed. In other words, the one-size-fits-all approach used at Yucca Mountain may or may not be the best approach. Number three, once a site has been selected, characterized, and found suitable, an engineering-oriented project plan for the design, construction, licensing, and operation of a geologic disposal facility for high-activity waste should be developed. At the same time, a scientific research program that is tailored to the requirements of the engineering plan and the repository site selected should continue in parallel, both for better technical understanding and identify potential improvements to the engineering plan. Okay, I hope that this brief representation of some findings from the board's work undertaken as part of the review of DOE activities has been useful. We look forward to providing other technical information to the Commission for its deliberations. And of course, all of our reports, correspondence, congressional testimony, and meeting materials are available on our website. I thank you, and I'm available for questions.
Thank you very much, Dr. Garrick, for a very useful and helpful presentation. Questions? Allison.
Great. Thank you very much. That was very interesting. A couple questions. One real quick one. You said reducing waste handling should be a priority. A repository design that accommodates the direct disposal of a variety of canister types should be considered. What do you mean by canister types? Materials? Different materials?
Well, the waste is shipped from the generator site in different canisters.
Yeah.
And they're not all the same, and some canisters are used for both the purpose of storage and the purpose of transportation.
Right.
And of course, the thought and the idea was to develop a waste package for the repository that would accommodate multiple canisters to avoid the need to have to keep handling the material.
Okay. At the end, you said, you talked about we should consider whether this one-size-fits-all approach is not suitable. What do you mean by that?
Well,
do you mean to imply that we need more than one repository, that we need a different repository for each different kind of high-level waste? Or?
I only make that comment because we may want to consider something like that. The whole issue is the integrity of the waste farm under the environment that you're going to put it in. For example, in Yucca Mountain, which has a high silica content, probably borosilicate glass waste would be more resistant than spent fuel. On the other hand, if you're going to put
well, it has nothing to do with the high silica content. It has to do with the oxidizing environment.
Well, that's true, but the silica content does contribute to, is more compatible with a glass waste farm than it is with a
I think it has to do with the oxidizing environment. I mean, all rocks have a pretty high silica content. And then finally, there are you make lots of statements about the ability of models to predict repository performance. So I want to understand whether you think that means the current method of U.S. evaluation of a repository, in other words, the licensing decision is currently made based on the results of this very complex and multi-layered model. Do you think that's reasonable, or should we consider alternatives?
Well, I think my main point there is to simply say that if we keep recycling the performance assessment back to the characterization program in the sense of being able to expose just what it is to quantify the performance, we're probably going to make the characterization program much more specialized to the needs of performance assessment. And this was particularly true where you have a situation where you have the kind of coupled processes that you have in a geologic disposal, of thermomechanical, nuclear, and so on. It isn't just a flow model. It's much more complex than that. Right. And the waste farms become very critical with respect to that.
Thank you. Richard?
Thank you, John. I really very much appreciate your presentation. I have a couple of questions as well. I know that you're familiar with the Academy report that had argued for an adaptive management approach,
right,
recognizing that there are lots of, as you noted, there are surprises, and that you need to basically a strategy of preserving options as best you could until you really had to make decisions, and preserving optionality for as long as possible. You didn't explicitly endorse that type of approach, and it is a little bit inconsistent with your statement about the problems of institutional stability.
The problems of what?
Of institutional stability,
right,
and institutional capability to still be there to make the decisions. I wondered whether you spent a lot of time on this subject, as to whether you had some views on whether the adaptive management approach that was advocated by the National Academies is something that should be an appropriate strategy for this commission to consider.
Yeah. Well, I think it very much is. I think it goes back even further than that Academy study. The original Academy study on rethinking high-level waste had some of the same kind of elements to it, that this should be done very systematically and very well-defined parts, and it should be designed, the project should be designed in such a way that the output from the previous part can affect the succeeding part. So I think the phased approach, and it really depends on what we mean by phased approach, or the adaptive approach, is absolutely critical, because this isn't a case where we have all the science we need when we start. We're developing science as we go along that is going to impact the engineering. And you need to have a project plan that accommodates that. So I'm very much supportive of an adaptive and phased approach.
I'd like to ask a question in a different area that does pick up on a point that that Allison has made, I think, twice this morning, which was that one of the lessons perhaps we ought to learn from the foreign experience is that if we were to think of a new repository, we ought to think about a reducing environment rather
Yes.
than an oxidizing environment.
Yes.
I wondered whether the NWTRB had taken a position on that and have views on whether you have views on it.
Well, I don't know whether we've taken a position on it, but I think that there's no question that that what we've learned is that the Yucca Mountain site is not dry. We all realize that the principal mobilization vehicle for waste is water, and some of the original thoughts about the dryness of Yucca Mountain were certainly determined as we got underground and as we did infiltration studies to not meet the requirements of the so low of infiltration rate that the real asset for that site would be that basically there was no water. Well, that was turned out not to be the case. So, yes, it certainly seems to be much easier to be thinking in terms of a reducing environment, which generally means the radionuclides are less soluble, and number one, and number two, the corrosion rates are much less too.
You mentioned that you're doing a white paper on the DOE research relating to the long-term storage of spent fuel. And I'm curious, first of all, when is that would be extraordinarily valuable to us. I'd be interested as to when that would be available. And secondly, does it encompass the research that's being undertaken by EPRI and others on the specific problems with commercial fuel?
Yes. Fortunately, we have with us today the board member that's leading that effort, Andy Kadak. I think the answer is that we're going to try to get the paper out before the end of the year. Is that right, Andy? That sooner than that? Yes, I think that every effort was made from at least a literature search standpoint to take into account all the work that's been done, including the EPRI work.
You've mentioned, let me just say that you've mentioned a number of reports that you are doing that bear directly on the work of this commission.
Right.
And it would be extraordinarily valuable that when those would be very, very valuable to us, and we look forward to receiving them at the earliest time that you could transmit them.
Yes.
So thank you.
Thank you.
Phil?
First, I wanted to ask a substantive question and then an institutional question. On the substance, one of your conclusions was that we've learned that it's possible to meet the NRC licensing requirement to submit an application. I wasn't sure whether that's just we've seen it happen because they accepted it, or whether there's a more serious conclusion here, and that is that some people are disputing the question about the million-year and the 10,000, standards that we've set up. Was that conclusion that it's possible to meet those standards?
Well, I think I have to choose my words very carefully here, because certainly the Nuclear Regulatory Commission did not reach a finding or conclusion relative to that application,
right,
except that it had met the requirements that they had for the application to be accepted. You can't just take an application and dump it in the doorstep of the NRC and expect it to be considered. It has to fulfill certain specific requirements, and those are not trivial. Those are pretty demanding, and so the whole point was that at least we've crossed that milestone. We know we can develop an application that meets the requirements for it being accepted for review.
Let me ask the institutional question, and probably ought to hear from your critics, and I'm not sure there are any, but one of the major things we keep learning is how poorly we've done in defining the government on institutions by which we manage this issue. And of course, the reason this board was established was to try to answer the charges that were very prevalent at the time that this science was constantly being perverted by the political process. And so this was to try to insulate that from the process. Indeed, from even the appointing process is very unusual in the federal government, where the president doesn't have total latitude as to whom he picks. And so I'm just curious if you can give us any insight into how you find Are there any additional safeguards to protect the scientific inquiry needed? Are there capacity issues? Are there, is there anything we should learn going forward about making use of this particular institution or some variation on it?
Well, I think one of the things that you probably thought of when you participated in the creation of the legislation behind the formation of the board that was extremely valuable in assisting the board in its technical evaluations was to make essentially pre-decisional information available to the board. In other words, we had access to draft material. We didn't have to wait until these reports and all of the material became legal, or official from the standpoint of going through all the review process before we could have access to the data and information. I think in general the board has been rather pleased with the access it's had to the information. We didn't always get it in as timely a fashion as we'd like, but we were always able to eventually get what we needed to do our job, which was a technical evaluation.
Can I ask you just one further on that? Is my vague recollection is, of course, that one of the things we wanted to do also was to make it possibly a whistleblower institution in which internally within the DOE or externally in Nevada or anywhere else, people could bring to you issues and say, come on, folks, look at this, or something. Has that been a part of this, or can you give me any?
Well, yes, I think it was. We instituted the same thing that you do here. We at all of our public meetings allocated time for anybody to come forward and talk to the board and whoever was there. And we also encouraged people to send in information and make it a part of our proceedings for that meeting if they were unable to have sufficient time to make their points at the meeting itself. So I think that the operational aspects of the board and its accessibility and the accessibility of information was one of the things that I very much enjoyed in our deliberations.
Thank you. Barry.
Dr. Garrick, I'd like to start with a comment and then follow with a question. The comment relates to the importance of having an independent scientific and technical review capability as the NWTRB provides.
After the discussion yesterday about the meaning of independence, I'm not sure.
I would just go on to say that we found that in Sweden, Finland, elsewhere, successful programs have some sort of independent, credible scientific technical review group that provides an independent source of information and review. That's only possible because people like yourself are willing to give an enormous amount of time and devote an enormous amount of effort, and also you have I would say, a gifted and highly capable staff. And I'd just like to, my comment is to just recognize your service to the nation and the deep appreciation I think we owe you for taking so much of your time to do this work, because it is important to the country to have your expertise and that of the other members of the NWTRB.
Well, I very much appreciate that, and I'm sure all of the previous chairmen would appreciate that as well. So this has been a very satisfying experience in being able to conduct the reviews we've had and had the staff, the quality of staff we have. It's made the job ever so much easier than it might have been otherwise.
If you don't mind my interrupting, I just think that's well said and well deserved, and the truth is that we are so poor in this town and elsewhere in this country of recognizing people who give genuine public service, and I think we should applaud that.
Thank you. Thank you very much.
My question is, you have a bullet point, major advances have been made on quantifying the risk of geologic repositories that also enhance the efficiency of site characterization. This is a very important point. As you know, we clearly have the need to fix the institutional framework, which is responsible for trying to carry us forward. And this is something that I hope Congress will take up and work on. There will be controversy, though, about the question of going back to a clean slate and looking for repositories. And a lot of that will, I think, be centered around skepticism about taking another who knows how long to try to do something once again. So I think it's important for us in laying out a reasonable timeline for how site identification, selection, and ultimately licensing process might proceed, to actually have some idea of how much time, given current state of knowledge, which is much deeper than what we had 20 years ago, it would take to perform, say, a preliminary site characterization. That is an activity that local communities might sponsor to determine in sufficient detail the characteristics of a site that would allow for an informed decision about whether or not it's suitable for hosting a repository, including perhaps, say, drilling of boreholes, seismic information, other things of that nature. In the modern world, how long might that activity take? And then subsequently, how long might the detailed site characterization take to provide, including, I guess, underground facilities, the level of information needed to license a facility? And I don't ask you to do this off the top of your head because it's important, but if you could maybe speak to that briefly, and then I think this is a question that we could benefit from NWTRB's assistance on, to understand what are these time frames necessary for preliminary site characterization activities, again, sufficient to inform a decision on moving forward for detailed characterization, licensing, and construction, and then that detailed characterization.
Right. Right. Well, first let me say I'm very pleased that you recognize that as an important experience finding, because I think it's one of the most important. And it sort of reminds me of the old carpenter rule: is you measure twice and cut once. And the analog here is characterization is the measure. And I think that one of the things that we found out in the Yucca Mountain project was that the analysis is much, much, much more than a water flow model. This came about particularly with respect to the thermal issues that were developed and the couple of processes associated with trying to model things where there was interactions between thermal effects, chemical effects, mechanical effects. And so I don't know that I can answer your question, but I do know that the characterization program that was invoked for Yucca Mountain was without the benefit of really the kind of hindsight we now have as to how we would go about doing it. And I think that whatever time we spent on it, we probably should double it in order to specialize the information to what we're trying to measure at the site with respect to risk and performance. And that's what I'm really talking about. The best way to find out what we need to do with respect to characterization and with respect to making measurements is to try to calculate it. Your old professor, Tom Pickford, used to say many times that the best way to learn about something is to try to calculate it. And we weren't there to try to calculate infiltration rates alone. We weren't there to try to calculate just radiation dose. We were trying to figure out how all of these phenomena interacted with each other with respect to the figures of merit that would eventually establish whether or not this was an acceptable site. So I think if there's an opportunity to really streamline the next time around, it would be to pay a lot more attention to site characterization than we did. And the reason this came about was that whenever we were reviewing the technical aspects of the total system performance assessment, one of the areas that we struggled with was trying to relate it back to the supporting evidence that was developed during the site characterization. And in many cases, we couldn't do that. And I think that's where some of the greatest benefits can accrue with respect to eventually having the construction process and the engineering process efficient.
Hopefully life might be a little easier with a saturated site.
Well, it might be.
I guess the key thing it would be very valuable to us, I think, for potentially even broken down by different geologic media and repository design options, to have some idea as to what the timeframes might be to perform appropriate site characterization.
Well, I think you need to perform performance analysis in advance. This is one thing we learned in the reactor business that was extremely valuable. When we started doing phased risk assessments, it turned out to be enormously beneficial in terms of returns on operations and maintenance as well as design and construction. So I think that these are just some backup slides that we... I agree with you, and I think that that's where a lot of very careful planning needs to be done, is on the front end. One thing I don't want to leave the impression, because my geochemist friends on the committee maybe would not like that, we're not suggesting here that you can't build a repository in an oxidizing environment. There are ways of doing it, and I think that the issue here is more how you keep the water away from mobilizing the waste, and also waste farms do become important under those conditions.
Did you have a question, Sue?
I don't know whether I have a question or not. This issue of water is extremely interesting. It keeps coming up. It came up this morning before the coffee break, and you mentioned it in your comments about Yucca Mountain. A number of us here on this commission just got back from Sweden, and it's pretty stunning to note the water that's cascading down the sides of the tunnel there underneath the Baltic Sea. I was wondering if you could help us, for those of us who are not scientists on this commission, to clarify this water issue a bit, and whether it relates to permanent disposal. Was that the issue, or was it, would the water be less of an issue? I mean, it seems to me it would probably be less of an issue if you had, if it were interim storage. Let me just say one other thing in terms of the time frame that Commissioner Peterson mentioned. The thing that is stunning about the way the Swedes have themselves organized is that they have everything phased. They have an interim retrievable storage facility, and they have a special storage for low and medium level waste, and they're licensing a repository at the same time. But everything seems to have a process, and they do not keep used fuel at reactor sites. They begin to move it through a process right away. So I was just wondering if you could comment on any of those issues I just noted.
Well, I think that the one thing that is absolutely clear to us, and that we struggled with in developing the corrosion, an understanding of the corrosion potential, is that you have to understand the chemical environment and the compatibility of that chemical environment with the waste farm that you're dealing with. And that's one of the reasons why it may be more of a challenge than we need to be thinking in terms of one environment handling all waste farms. There may be some merit in thinking about multiple geologic disposal, but we're not sure about that. It would be much easier, of course, if you had one that could fit, could handle anything. But it may turn out to be far more efficient to pay much more attention to the compatibility between the waste farm and the chemical, mechanical, and thermal environment that it's going to be in.
Dr. Garrick, we thank you very much for your presentation and especially for your dedication to this very difficult issue.
Thank you very much. Pleased to be here.